Hello everyone, this is Blender Guppy. Welcome to the main video tutorial for the Random Starship add-on. This add-on is designed as a utility or support add-on for random flow, but you can use it as a standalone plugin. To install the add-on, in the viewport, press F4 and go to Preferences. Go to Add-ons, then use the Install button on top. Once you see the file browser, look for the Random Starship zip file with a version number at the end, then use the Install button on that. There's going to be another zip file in the downloads, and that's for the presets. It has a separate installation video tutorial. Once installed, use the search bar and type the name of the add-on to quickly find it. Use the checkbox to activate the add-on. Inside the drop-down menu, you can find the Use Confirm or OK Redo panel. This will allow you to use the OK type or static redo panel instead. If using the default redo panel, which you can bring back using the F9 hotkey, but you're not seeing the same quick result as I am, go to System in Preferences, then toggle on Global Undo. With the add-on activated, you can find it in the Add menu by using the hotkey Shift plus A. You can then go to the Mesh submenu and find it on top of the default primitives. Now before we start making starships, let me first explain what each of the properties in the redo panel does. They are categorized based on their functionality. We have properties for the hull, the front and back of the ship, the plating details, the wings, and the settings. They may look overwhelming because of their number, but most of them are just there for more control over the shape of the resulting starship mesh. Once you get familiar with the add-on, you'll find that you need only fiddle with 8 to 10 properties at most, especially when you have your own saved presets. Before moving on to properties, when you use the Random Starship operator, the location where it will be created is in the position of the 3D cursor. This is the same for every primitive in Blender. Let's start with the hull properties. The hull section property refers to the number of extrusions that make up the body and length of the starship. The extrusion is randomized in the negative and positive y-axis of the starting hull section. This part doesn't move, as you can see in the location of the 3D cursor. The base or starting hull section is where the number of hull sections are added, so if you have one in the hull section property, in actuality you have two. The tolerance property determines the faces that are extruded in order to build up the hull section. The lower the values get, the flatter the faces needs to be in the y-axis direction. Raising the tolerance value means you will get more faces that tend to face towards the x or z axis. The triangulation property refers to the angle by which the faces will be triangulated. This is the main workforce for creating those interesting angular shapes in the body of the starship. It works in combination with the bump properties to triangulate faces that goes past the angle threshold. Changing the angle threshold allows you to control how much of the starship are triangulated to create those angular shapes. The hull length property, which has a minimum and maximum value, controls the length of each extruded hull section. The edge cuts property refers to the number of edge cuts placed on a hull section. This is randomized per hull section, with the values ranging from 0 edge cuts to the amount you entered in the count property. You can randomize their placement using the seed property value. The purpose of these edge cuts is to affect the shape altering properties below without using subdivision. The bumps, for example, will look different once you start adding more topology this way. You can also use this to change the size of the wings without actually subdividing the entire mesh. The base scale properties are used to scale the base geometry or starting hull sections in the x, y, and z axes. You can use these to create long, wide, or tall ships. The base rotation properties are used to rotate the starship object and the x, y, and z axes. This is useful when you have to quickly create a starship object on a particular spot with a specific rotation. Changing the rotation this way does not change the local orientation where the hull section are extruded or the base scale properties are scaled. Compared to the base scale properties, the rotation will not be applied, and you can reset this to the default orientation, which is facing the y-axis, by clearing the rotation or by using the hotkey Alt plus R. The bevel offset, segments, and profile properties are responsible for the starting shape of the hull. This bevel shape is key to how the bumps, the plate ensets, and the wing extrusions will come out. Just like the edge cuts, increasing the topology using the bevel segments will have major effects on the sizes of the bumps and wings and pattern of the plating details. With the bevel segments though, I usually work with just 2 or 3. The scale properties with a minimum and maximum value is responsible for the random scaling of each extruded hull section. It scales the extruded face in the X and Z axis with random values for each of them. When using higher scale values and increasing the number of hull sections, you will find that the hull sections can sometimes scale exponentially. A way to avoid this is by using the scale interval property. A value of 1 means that each hull section will be scaled, but using 3 for example means that the scaling will only happen for every third hull section. This will help normalize the scale of the hull sections and avoid it going out of control. The uniform scale is a percentage property where as you increase its value, the more the scaling of each hull section will be uniform. Or the scaling in the X and Z axis will eventually use the same value using 100%, and lower percentage will alternate between uniform scaling and randomized numbers for each axis. Now we come to the bump properties. This was a late addition to the add-on because I thought the earlier versions always result to an elongated shape format with no sudden breaks in its profile shape. This feature will allow you to raise up random edges, faces, or both depending on the bump mode, and combined with the triangulation property, make interesting angles in the Starship mesh. You can see that even with a base output with no details, the design can already be used for faraway renders or as objects in the background. It has numerous properties to control its result. We have the count, which determines the amount of bumps in the mesh. You can randomize its location using the seed property. The bump mode lets you choose what elements to bump up, whether it's edges, faces, or both. The bump limit allows you to limit the elements used for bumping. If you use none, this means that all elements will be used as bumps, but only once. Using adjacent means that an element will be used as a bump only once along with its neighboring element, thereby creating a sort of margin. The bump offset minimum and maximum controls the strength of the bumps. You can randomize them using the offset seed property below. This is one of the key features that shapes the Starship mesh along with the bevel properties earlier. Use them strategically for optimal results. The subdivision property lets you subdivide the entire mesh. The smooth property next to it is part of the subdivision command, and you can use it to smooth the result of the subdivision. Be careful on using too much because it can puff up the mesh, but you can also use this for additional effects if you wish. The half smooth property smooths the entire mesh after the subdivision or without it. This is different than the subdivision smoothing, and using too much of it can cause fractal noise on the geometry. You can use subdivision to increase the resolution of just a simple base mesh, or use it to increase the details resulting from the plating feature or affect the size of the wings. You can also use subdivision smoothing along with the half smooth property to smooth the initial base mesh, thereby affecting the result of the plating details. The triangulate property randomly triangulates faces with how many controlled by the percentage slider. Again, this is to change the output of the plating detail so the plates can have slanted edges. The hull shape property is the universal random seed control for the properties in the hull category. This is what you will mostly fiddle with above all other properties in the redo panel. The front and back properties deals with changing the shape of the front and back of the ship. These are the faces that are at both ends of the ship facing the y-axis. Raising the tolerance property will let you have more faces in the hull included as the front or back, but usually using the default value is already perfect. In this case, the tolerance property is exposed just in case you are trying for really weird shapes. These properties will also let the faces at both ends of the Starship base mesh have better results with bumps and plating details. The ship front property allows you to change or switch the front of the ship to the back. While the back of the ship can serve as the front anytime you like, this has more to do with how the geometry will change based on the other settings in the redo panel. This is one of those properties that are exposed only for special use case scenarios, but are mostly left as default. The tolerance values are also for special use case scenarios and are used to get the faces that are facing the y-axis. The front scale property is used to scale the front of the ship in the x, y, and z axes, while the back scale property does the same and scales the back of the ship. The smooth properties allows you to add smoothing to the front or back of the ship. Its main purpose is to unflatten the front and back of the base geometry so the bumps and plating details can have better results in these areas. I'd usually go for a value of 1 or 0.5. Using too much will eventually lead to overlaps, so be careful. The plating properties are responsible for the plate inset details should you decide to upgrade from a simple base mesh. This extrudes sets of faces in or out from the mesh resulting to unique patterns that can be randomized. You can come up with a lot of design combining this with geometry smoothing or with auto smooth. The plating property determines the amount of plating details you can put on the Starship mesh. This comes after subdivision, so the more you subdivide, the more faces it can work with. However, using too much can slow down the operator. The size property with the minimum and maximum value determines the size of each plates. One means just a single face, and increasing the value means the faces used will try to expand radially or in a circle. The size of each plates will randomize between the minimum and maximum value. The tolerance property is used to find faces for the plating details. The lower the value gets, the more it will try to get faces that has the same normal as the faces used in the plate inset. If you raise the tolerance, this will enable the plate inset to expand more by getting faces that differs from the average normals used by the plate so far. Think of this as selecting faces that has the same normals or plane. The adjacent faces property determines how the plate insets are initiated. Using clear means that the plate details start out with no adjacent or neighboring faces. Use this if you want to establish more rest areas in the Starship mesh. Using fill means that all faces will be used to start the plate details. Use this if you want a more detailed mesh with little to no rest areas. The way the plate insets are started using the adjacent faces property has an impact to how the plates expand using the size property. The thickness property scales the top part of the plate insets, while the depth property determines their height. The height property with a minimum and maximum value is also depth, but an added randomized value to the original depth property above. The margin property sets the margin for each plate detail or inset. Be careful on using too much because this can cause spikes on areas where smaller faces are compressed. There are two margin types you can choose from. Selecting all will create margin for all plate details. Unusing indent will only create margin for plate insets that extrude into the mesh. This is mainly to avoid the sharp borders two indents can make when they are created close together. The reverse depth property is used to randomly invert the direction of the plate detail extrusion. The number of inverted plates is determined by the percentage value. This means that a plate, which has a positive depth value and is extruding out from the mesh, will be reversed and will now be extruding in. The limit smooth property works in combination with the auto smooth properties in the settings category. These marks sharp the border edges on the top or bottom part of the plate insets, making it look different when using auto smooth. Using none will of course not mark anything. Using base will mark sharp the border edges at the bottom of the plate insets, making these areas sharp with the top part being auto smooth. Using top will mark sharp the border edges at the top of the plate insets, making them sharp with the bottom area being auto smooth. The marked sharp edges are also marked with seams so the mesh is easier to UV. This is only available when using the limit smooth base or top. So besides the changes in geometry, you can combine the effects of auto smooth along with mesh smoothing to get different designs out of your starship. The plating seed property is the universal random seed control for the properties in the plating category. If you like the shape of the hull but feel like you have to change the plate details, use this to seed through random results without changing the base mesh. We move on to the wings category. This is responsible for randomly creating wings or winglets throughout the starship mesh. This comes after subdivision and plating, so increasing the resolution and detail affects the way the wings are created. The wing count property determines how many wings can extrude from the starship mesh. By default, the mesh is mirrored in the x-axis. The mirroring comes after the wing extrusion, so in reality, the location of the wings are being randomized on an asymmetrical mesh. So if you don't see wing extrusions in the positive x direction, for example, this means all the wings must have appeared on the other side. The wing length property refers to how many segments the wings can have. The edge cuts property determines the number of edge cuts for each wing segments. Use this to increase the wing resolution if you have use for them after. The tolerance property determines what faces to use for the wing extrusion. The lower the value, the more the wings will extrude from faces that face the x-axis only. The higher the value, the more it will include faces, which also tends to face towards the y and z axis. The depth property, with its minimum and maximum values, determines the length of each extruded wing segment. The wing margin property sets the margin for the face the wing is extruded from. This is an extra control for the size of the wings. The wing taper property scales or tapers the wings. The wing smooth property smooths the wings since the wings are not affected by the hull smoothing. The wing rotation determines the rotation of the wings per segment. Use this to come up with really weird or alien looking ships. Then we have the wing seed property. This is the universal random seed control for the properties in the wing category. The wing extrusions comes last in the geometry altering properties, after the hull geometry changes, the bumps, the subdivision, the front and back changes, and the plating details. Use the wing seed property to randomize the wing location and appearance without changing the design that came before it. If you see wings that cross together in the symmetry axis and is disconnected from the starship mesh, you can use the wing count or wing seed property to randomize them out. Or you can just manually delete them after if you like the other wing locations. Finally, we have the settings category. This is where you will find the controls for the symmetry axis and where to flip them. The smoothing axis that determines which axis the hull smoothing will affect, the auto smooth, which auto smooths the mesh using an angle threshold, and the smart quantify, which quantifies the mesh but leaves the edges that makes the angular shapes intact. By default, the starship mesh will be mirrored in the x-axis. If you turn it off, you will find that the mesh is actually randomized first with symmetry off. This is true for the bumps, the plating details, the wings. Every one of these shapers are randomized asymmetrically before being mirrored on the axis of your choice. The flip toggle are only exposed for additional controls, but normally I just use the default direction of the symmetry axis. If you're taking your sweet time, then you can play around with these toggles. The smooth axis toggles works with the hull smoothing in the hull category. This is used to limit the smoothing on the axis of your choice. I exposed this for additional effects you can make since the smoothing comes first before the plating detail and the wings, and anything you do before them affects how they are made. The auto-smooth properties are used to auto-smooth the mesh depending on the angle threshold. This works in combination with the limit smooth property in the plating category, where you can control which part of the plating insets to limit the effects of the auto-smooth, thereby changing the way the ship looks. Also, using any amount of plating detail will mark the mesh for UV unwrap later. Some parts of the UV may still need additional work, but most of it has been done for you. Even the wings will be properly UV marked. The Smart Quantify is used to quantify the triangulation done to the mesh to create the angular shapes. Using the angle threshold, this will keep the angular shapes intact while quantifying the rest of the triangulated faces. Using 15 or 30-degree angles is enough for most situations, but you can copy the angle you used in the triangulation property in the hull category to have an exact quantification of the faces involved. The presets folder will have a different installation video, and the link will also be in the product page. This will let you play around with the add-on quickly after installing it. And this concludes your introduction to the Random Starship Redo Panel properties. Watch the next video where I build different designs using the presets or build one from scratch and let you know which properties are going to be mostly used. Thank you for watching and have a nice day.